Okay, so again, we're in a non-right triangle. So we don't have Pythagorean. Law of cosines is the correction to Pythagorean, and it's c squared equals a squared plus b squared, looks like Pythagorean so far, minus 2ab cosine of the angle C. So let me make this guy nice and big and capital. That's the angle C. These are all sides. So this here, this term here is the correction term for non-right triangles. But C now is nothing special. There's nothing special about that angle C. If you Google law of cosines, this is the formula you'll see written down. But I could write out the same formula for either of the other sides. I could write, let's notice the pattern here. A squared should be the other two guys, b squared plus c squared, minus twice the other two guys without the square, bc, cosine of his angle, angle A. Notice those two go together. And similarly, to AC, see, so I got the B there, so these will be A's and C's, cosine of angle B. The B's go together. So we never know which version of this we're going to need. So I don't have all three of these memorized. I have this one memorized, and from that, I can figure out the other two. All right, we use law of cosines in two different scenarios. We use it in side angle side and side side side. So let's do a side angle side problem. Let's say I know this is 8 feet, 10 feet, and 27 degrees. So if I'm going around, I know a side, then an angle, then the next thing I know is a side. Side angle side. Remember, our final answer is going to be this table. So we're going to write out this entire table. If a question says solve the triangle, if it's a written question, this is what we're going to circle. All right, what do we know? We know A is 27 degrees. Don't forget your degree symbol. B is 10 feet. C is 8 feet. You can try all you like. You absolutely cannot find these two guys. The only thing you could find, no matter what you try, is side A. And we're going to have to do A squared is B squared plus C squared minus 2BC cosine of A. Little a is the one I'm looking for. So I'm using that version, the one that has the little a in it. Notice I also know cosine of A. I know B and C. I know everything over here. That's the only thing I don't know. So A squared, I'm going to write it all out, will be 10 squared plus 8 squared minus 2 times 10 times 8 times cosine of, what was my angle? 27 degrees. All right, let me pull up my calculator and show you what that looks like. Come on, in this one. Okay, so we want to type this into our calculator. We want to make sure we're in degree mode. So go into mode, I'm in degree mode. And so I'm going to type it all out, even though we could, like we know what 10 squared is, right? I could just type 100 plus 8 squared minus 2 times 10 times 8 times cosine of, I think it was 27 degrees. Hit enter. That's b squared. That's not, who was it? A. That's a squared is 21 point, we'll go 2 places, 44. I don't want a squared, I want a. I want the square root of that answer. So my calculator could do that pretty easily. We go back to the share. So I could type that in, or I could just hit second square root, second answer. And there we go, 4.63. So 4.63, what are my units? Feet. We want to make sure we have units here. We found that, let's circle it. All right, now I need to find either A or B. Once I get one of these angles, the third one, I just use 180 degrees in a triangle to find the third. So I need to figure out one of these two angles. We could use law of cosines again, but using law of cosines to find an angle is a lot of work. And there are a lot of ways you can type it in wrong. A lot of mistakes happen. So my recommendation now is to switch over to law of sines. Now remember, law of sines, when you're looking for an angle, you can't trust it all the time. Inverse sine, this function on your calculator will never spit out an obtuse angle. So if I'm going to be using this button on my calculator, I want to make sure I'm looking for an acute angle. B might be obtuse. B is the biggest angle. It's the biggest side. So I'm going to use law of sines to find C. So look for the smaller angle first in this scenario. It'll save you some trouble. Look for the smallest first. So we want to look for angle C. So sine of C, angle C over little c will be, I only know A's, so sine of capital A over little a. That means sine of capital C will be C sine of A over little a. So I just multiplied the little c up. So that will be 8 sine of 27 degrees divided by 4.63. So whatever that is, I'm going to do an inverse sine of that. C will be inverse sine of that number. So let's type that in the calculator. So what I have, 8 sine 27 divided by 4.63. I'm going to do an inverse sine of that answer. $51.67 degrees. Don't forget your degree symbol. And then the last one will be 180 minus that. I'll switch back in a second. So I want 180 minus that answer and minus 27, which was, who was that, A? 101.33. So now I've got B also. Notice B was an obtuse angle. If I had used law of sines, if I had done all of this with B's, my calculator would have given me the wrong answer. It would have given me the quadrant 1 version of that angle, which would have been 79 degrees. I would have gotten the wrong B and the wrong C. That's why this is important. Or we could have just used the law of cosines. Law of cosines, there's no ambiguity. It always works. Problem is, it's more work. All right, now let's do a side problem. So here we know all three sides. We don't know any of the angles. Say that's 5 meters, 7 meters, 9 meters. So I've got ABC. So what do we know? Here's B, here's A, here's C. 5 meters, 9 meters, 7 meters. We had to find an angle. Law of sines won't work here. No matter what you try, you're not going to get anything out of it. You always have two unknown angles. We have to use law of cosines. A triangle can only have one obtuse angle. So my recommendation in law or in side problems, the opposite of what the other one was, look for the biggest angle first. If there is an acute or an obtuse angle, law of cosines will give me that. And then once I get that, I know the other ones are acute. And if I switch to law of sines, I don't have to worry. So who's my biggest angle? That'll be the one that goes with the biggest side. That will be B. So I want the version of law of cosines that has B's in it. That's going to be this one. Because B is the biggest angle. It goes with the biggest side. Now, here's where mistakes happen. People will do this. They'll type this in the calculator. Let's write out what we know. 9 squared equals 5 squared plus 7 squared minus 2 times 7. Oh, not that it matters, but I wrote those in the other problem. Times 5 times cosine of B. People will type all of this right here into their calculator. And that's an order of operations issue. That's wrong. That stuff is not all, that's not all that multiplied cosine. That stuff right there is multiplying cosine. So you could solve for this algebraically, get everything to the other side and type it all in once. I don't recommend that. In fact, I see that go wrong a lot. I recommend let's do a couple of simplifying steps first. Then we'll type in once we've simplified. Like here, we know that's 81 equals 49 plus 25. And then all of this is multiplied together. So that would be 14 times 5, that's minus 70 cosine of B. Again, all of that is multiplied together. So let's move these guys to the other side. So I'm doing 81 minus 49 and minus 25. I'll write it out for you. So let me see what that is. I won't pull it up, but 81 minus 49 minus 25. 7. Then, and only now, can I get rid of this stuff that was in front of the cosine, divide it over. Cosine of B will be, if I divide that, 7 divided by negative 70, that's negative 0.1. Now I can do an inverse cosine, and you might be thinking, wait a minute, how can cosine be negative? Cosine is negative in quadrant 2. That means B is an obtuse angle. So then B is the inverse cosine of negative 0.1. So inverse cosine, second cosine, negative. Remember your negative button is here. That's your minus button. 0.1. 95.74 degrees. Anything I found myself, I like the box. Okay, now we have to find either angle A or angle C. I prefer, because this was a lot of work, we could do it again. There's nothing wrong with that. We could use this same process with either the A version or the C version, find angle A or angle C. But there are a lot of places you could make a mistake in here. Law of sines is more forgiving with algebra mistakes. So I'm going to switch over to law of sines. So I don't know, we'll find A. Sine of A over little a is sine of B over little b. Technically, right now, we're in a side-side angle situation. This is the ambiguous case, but we don't have to worry because we know both A and C are acute angles. That guy was obtuse. We could only have one obtuse angle in a triangle, so we don't have to stress about it. We can trust our inverse sine. So I'm trying to solve for angle A, get that guy over. B, that will be 7 sine of 95.74 degrees divided by 9. So A will be the inverse sine of whatever number I get there. So 7 times sine of that last answer. I'm lazy. I could type that out, or I could just say second answer. And then that was divided by 9. I don't know why my screen's all ugly like that. My computer's being weird. And then I want to do inverse sine of that answer. Enter 50.71. Degrees, that's angle A. And then to find the last one, all three of these have to add up to 180 degrees. So just do 180 minus those two. Okay, I'll let you guys do that on your own.